So for the last lesson of this unit, we're going to be talking about compositions. And so first thing, let's go ahead and recall that given function f and its inverse, the f of -1, if x is the domain of both functions, then the f, let me go ahead and adjust the size of that. The f of -1 of x will just wind up being x, and then vice versa. So if we take the inverse of the f of x, then that will also be just x. So a composition of the inverse cancels the other. So we also have to deal with the same domain restrictions though, for our functions and our inverse functions. So if -1 is less than or equal to x, which is less than or equal to 1, then the sine of the arcsine of x is going to equal x. And if -1 is less than or equal to x, which is less than or equal to 1, then the cosine of the arccosine of x is going to equal x. So these will cancel each other. And then if -infinity is less than or equal to x, which is less than or equal to positive infinity, then the tangent of the arctangent of x will equal x. So now if we switch those things around, then we will have to look at x in a different way. So if the negative pi over 2 is less than or equal to x, which is less than or equal to pi over 2, then the arcsine of the sine of x will equal x. And then if 0 is less than or equal to x, which is less than or equal to pi, then the arccosine of the cosine of x equals x. And then if the negative pi over 2 is less than x, which is less than pi over 2, then the arctangent of the tangent of x equals x. So let's go ahead and look at some of these values. So remember, when looking at compositions like this, always check your domain first. And make sure you are within it. So we have first the sine of the arcsine of the -1/3. So for sine, we need to be between -1 and +1, and we are. So this means that these two functions can cancel each other, and this equals a -1/3. So then for number 2, we have the cosine of the arccosine of 2/5. And cosine has to also be between -1 and +1. And so these two can cancel each other, and this equals 2/5. So then next on number 3, we have the cosine of the arccosine of 3/2. And so remember, we have cosine, so this has to be between -1 and +1. And so 3/2 is larger than 1, which is outside of that domain. So this does not exist. Then on number 4, we have the tangent of the arctangent of -9/2. So tangent can be between negative infinity and positive infinity. So this does work, and so we have -9/2 as the result. And then we have the tangent of the arctangent of 1/4. So those two will also cancel each other and just give us 1/4. And then now we have the sine of the arcsine of -7/6. Again, this is where x has to be between 1 and -1. And so this is lower than -1. Which means that it does not exist. And then on number 7, we are switching this around to we have the arcsine of sine. So this has to be between a -π/2 is less than or equal to x, which is less than or equal to π/2. So π/4 does fit in between, so these will cancel and you have just π/4. And then for the arccosine of cosine of 5π/6, remember we have to be between 0 and pi. And 5π/6 is between those two values. So this is 5π/6. And then we have the arctangent of tangent. So we are looking at being between -π/2, but remember that this is just less than, not less than or equal to, which is less than π/2. And so since we have a -π/2, then this is not in the domain. And so this value does not exist. All right, so then on these next few problems, we are going to be looking at some that actually the value is beyond what the angle can be, but if we can rewrite it using an angle with an equivalent trig value that is in the domain, then it will be fine. So first we have number 10, we have the arcsine of sine is 3π/4. So 3π/4 is outside, but if we look on our unit circle, then we see that 3π/4 has the same sine value as π/4. So we're going to rewrite this as the arcsine of the sine of π/4. And one reason why this works is we have the same trig value, or the same function value. So we can then cancel and just have π/4. And the same thing here with arctangent and tangent of pi. Pi is not in the domain of arctangent, but if we look instead at the arctan of the tangent of 0, then this will work because the tangent of pi is equal to the tangent of 0. And so this is an equivalent value. If we look at number 12, we have the arcsine of sine of 11 pi over 6. So in this case, we just need to actually state this differently. So instead of 11 pi over 6, we could use the negative version of that angle on the unit circle, which is negative pi over 6. These also, of course, since they are coterminal angles, will have the same function value. So that's negative pi over 6. And so that is another way. So let's look at now 13. We have the arc cosine of the cosine of negative 4 pi over 3. So this is also a negative angle, so we could express it as coterminal and actually be in quadrant 2 where we need to be. So we could rewrite this as the arc cosine of the cosine of 2 pi over 3. And so that gives us 2 pi over 3. And again, these are coterminal. So they wind up being the exact same value. Okay, so now we're going to make it a little bit more interesting. And we are going to mix up our functions. So instead of having the exact same one, so what we will do is we'll work from the inside out to find the exact value. So we're going to start with the sine of pi over 6. Now I know that the sine of pi over 6 from my unit circle is, 1/2. So we're going to have the cosine of negative 1, or the arc cosine of is 1/2. And so then if I go in my unit circle and find where 1/2 is in either quadrant 1 or 2, that gives me pi over 3. So that is my final answer. Then for 15, we're going to look first at the cosine of 0. The cosine of 0 is 1. So we're going to have the arctangent of 1. And so I'm going to look in quadrants 1 and 4. And that gives us pi over 4. Then for number 16, we have the tangent of negative pi over 4. So the tangent of negative pi over 4 is negative 1. So I'm going to look at quadrants 1 and 4 and find where I have a sine of negative 1. And that is negative pi over 2. So then for 17, we have the arc cosine of the tangent of pi over 4. And so the tangent of pi over 4 is 1. So I have the arc cosine of 1, and that is 0. Then for the cosine of the arcsine of 1/2, I'm going to look in quadrants 1 and 4 and see where I have a angle that is 1/2, and that is going to be pi over 6. So then the cosine of pi over 6 is the square root of 3 over 2. Then for 19, I need the arc cosine of 0 first. And that is at pi over 2. Because I can only look in quadrants 1 and 2. So the sine of pi over 2 is 1. So now let's look at what happens when we have non-unit circle values. So the first thing we're going to do is we're going to let that inside value equal theta. And then we will determine which quadrant theta has to be in order to have the value that it does. And then we're going to draw a right triangle and find the missing side using the Pythagorean theorem. So we've done this quite a bit already this year. Then we'll evaluate the outside trig function based on what we find. So it's going to be okay. We're going to get this figured out. All right. So what we're going to do is we're going to first let the inside equal theta. So we're going to have theta equals the arc cosine here of 8 over 17. And so to undo that, we're going to have cosine. So we're going to have cosine theta equals 8 over 17. And so here we know a couple of things. First of all, cosine is positive, which that happens in quadrants 1 and in quadrant 4. And then arc cosine is restricted to quadrant 1 and quadrant 2. So therefore, since quadrant 1 is in both of those characteristics, theta is in quadrant 1. So then when we go and evaluate for tangent, we know it's in quadrant 1. So let's go ahead and look at what we know so far. So we know that cosine of theta is equal to 8 over 17. So if we draw ourselves a triangle, we have cosine. So we have the adjacent side is 8. The hypotenuse is 17. And then we have to use the Pythagorean theorem to find that missing side. So this would be our y. So we're going to have 17 squared is equal to 8 squared plus y squared. 17 squared is 289. 8 squared is 64. And then we're going to subtract 64, which gives us 225 equals y squared. And so that gives us 15. And so we have now our adjacent side. So if we're looking for essentially where theta is, that means y is my opposite, and tangent is always y over x. So our tangent, our y is 15, and then our x is 8. So our final answer here is 15 over 8. So let's go ahead and do this one more time. So we have the sine of the arctangent of negative 12 over 5. So we're going to let theta equal the inside function again. And then we are going to, of course, take the tangent of each side. So the tangent of theta is going to be negative 12 over 5. And since tangent is negative, we know two things. Tangent is negative in quadrant 2 and quadrant 4. And then arctangent is restricted to quadrant 1 and quadrant 4. So since quadrant 4 is in both of those, quadrant 4 is where theta is. So now we're going to go ahead and draw our triangle, and we'll find that missing side. So we have, let's see, so we're given tangent, so that is y over x. So we have negative 12 and then 5, and we are looking for the r. So we have the r squared equals negative 12 squared plus 5 squared. And we have 144 plus 25. So r squared equals 169, and r is equal to 13. So then we are going to go find the sine of theta. So the sine of theta is going to be our y over our r. So that's going to be negative 12 over 13.